first section in chapter 6 on matrices, and this is an introduction to matrices. Now you can think of a matrix, so singular is matrix. Let's get this out of the way first, and plural is matrices. You can think of a matrix like a big vector, okay, or a vector with more numbers. Okay, so we're used to seeing a vector written that has maybe two numbers like this, 5 and 6. A matrix is just a bigger version, so you might have 1, 5, 0, negative 1, 2, 3. That's a matrix. Here's another one, 5, a half, 0, 2. Here's a matrix. Happen to have the same amount of numbers going across and up. Here's a matrix. Nice pattern, 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, these are all examples of matrices. Now, we need to be able to know some terminology with matrices. We're going to be doing all sorts of calculation with them. The first thing is here, it talks about a square matrix. So a square matrix is where the number of rows and columns is the same. So here's a square matrix, 1, 0, 0, 1, yeah. So it's got 2 columns, 1, 2, and 2 rows. Here's another one, 1, 0, 8, a half, negative 1, 0, 5, 2, 3. Okay, so that's another one. It's got 3 rows, 3 columns. Okay, so the first one we would call a 2 by 2 matrix. So we just write 2 times 2 like that. This would be a 3 by 3 matrix. Again, we just write 3 times 3. So it's a matrix that's either like 2 by 2, 3 by 3, 4 by 4. In general, n by n. So n rows times by n columns, where it's the same. So that's a square matrix. A zero matrix, is the second one, is basically where every number in the matrix is 0. Now it talks about elements. Basically each number in the matrix is called an element. So let's write that down. Each number in the matrix is called an element. So you might talk about the number of elements in a matrix. So a 2 by 2 matrix has 4 elements, 3 by 3, 6 elements, and so on. If all of the elements, if all the numbers in a matrix are 0, it's called the zero matrix, funny enough. Now, rather than having to write out a big matrix full of zeros, so I don't know, here's a 3 by 3 matrix, a square matrix that's full of zeros. We can refer to that as a 0 underlined, like vectors. That means it's a matrix full of zeros. That might be one that's square, it may be rectangular shaped, it may have, it may be of any size, but all of the elements, all of the numbers in it are zeros. Then the next thing we've got here is something called the identity matrix. It's an important matrix in terms of when we're going to be doing like multiplying matrices, and it's a matrix. You can see here all of these elements here, all ones, and every other element is 0. So these are all zeros down here. When we have that pattern in what we call the leading diagonal, so basically this diagonal here is called a leading diagonal. When they're all ones and everything else, every element is 0, it's called the identity matrix. So This one here is indicated as I3. I for identity, we'd underline that. When we talk about matrices and capital letters or letters we use underline them like vectors, because remember it's just a big vector. So I means identity, meaning all these leading zeros, so all the numbers on this leading diagonals are 1, and 3 indicates that it's a square matrix, a 3 by 3, and these identity matrices are only ever square matrices. You won't get one that's like this shape over here or this one. Okay, so I could have, for example, the identity matrix of a 2 by 2 matrix would look like this. So along the diagonal is 1 and every other element is 0. If I had identity matrix for the 4 by 4 matrix, square matrix, then along the leading diagonal 1, 2, 3, 4, they're all 1s. Every other element is going to be 0, and it forms this pretty pattern, and it's going to be useful later on. Now, what if a matrix isn't square? Well, up here, I've got an example of a matrix that isn't square, and it's described as a 2 by 4, 2 times 4 matrix. Now, the first number, the 2, indicates the number of rows, and the 4 indicates the number of columns. So this would be 2 by 4. So when we describe the size of a matrix, so the size of a matrix is given by number of rows. So that one highlighted blue had 2 rows and it had 4 columns, number of columns. And that's how we talk about the size of a matrix. Okay, let's have a look at a couple of examples. Right, write down the size of each matrix in the form NM. So N is going to be the number of rows. That number comes first, number of rows. So you could almost think of it as like the height of the matrix. And then M is going to be the number of columns. And you could think of that almost like the width of the matrix. So A, well, that's 2 by 2, and it also happens to be a square matrix. B, that is 1 by 3, so it's got like a height of 1 and width of 3. C, 2 by 1, and D, 3 by 2, so the height by the width. Right, now here we're adding matrices, and the way it works is that every element here in the first matrix needs to be added to the corresponding element in the second matrix. So you'd add those together, get an answer. You would add these ones together, get an answer. You would add these together, and then you would add like these together. Yeah, so every element must be added to the corresponding element in the second matrix, which does mean that you're not going to be able to add matrices where they're of different sizes, of different dimensions. So in part A, so what we're going to do, I'll write it out in full. The first element is going to be 2 plus minus 1. The second element is going to be negative 1 plus 4. The third element is going to be 0 plus 5. And the last element is going to be 3 plus 3. So we'll work those out. So we'll get 1, 3, 5, and 6. So that would be your final answer. So it says here that, I was going to write a sentence down, but it says here that, you know, we can only add or subtract matrices which are the same size. They must have the same dimensions, the same height and width. If they don't, you can't do it. Right, part B. So first element is going to be 1 minus 0. They're the first elements in both. Then we have negative 3 minus 2. Then we have 4 minus 1. So we take away all the second elements from the first one. Then we have 2 minus 5. Then we have 1 minus 2. And we have 1 minus 3. Okay, I'll write this out. Normally you'd sort of work them out in your head and write them down, but I'm just showing you how we get each element. So 1 minus 5, 3, negative 3, negative 1, negative 2. So there we go. So that's how we subtract matrices. That's how we add matrices. Right here, we're going to have a number in front of a matrix, which we call a scalar. And whenever you have a scalar, a number in front of a matrix, you multiply every element in the matrix by that scalar. It says it here. I can't probably say it better than that. Yeah, every element in the matrix gets multiplied by the scalar. And here we're just using some letters to represent a matrix. So part A, if I'm doing 2A, I'm basically doing 2 lots of this 1, 2, negative 1, 0. So multiply every element by 2 and get 2, 4, negative 2, 0. It's a square matrix there. See, the 0 element will stay as a 0 element. Part B, do half of B. So half of the matrix B is 6, 0, 1, negative 4. So every element gets halved. So 3, 0, negative 2. Probably should space them out a bit more. Yeah. Notice that with addition or subtraction, the matrix doesn't change size. It's the same size as the one that you started with. And then part C says, explain why you can't work out A plus B. Okay, we can't do A plus B, underline them, A plus B, since they have, or because they have different dimensions, different sizes. Yeah, A is a matrix which is 2 by 2. B is a matrix which is 1 by 3. Okay, and we can only add matrices if they have the same size. And these don't have the same size. They need to be identical. In that way, I think it's called like additively comfortable or something like that when they're the same size. Right, so here it's almost like an equation. What are we doing? We're doing 2 lots. We're not. We're just doing A, which is A 0, 1, 2, and we're adding to that 2 lots of B, which is 1, B 0, 3, and that equals C, which is 6, 6, 1, C. Okay, and I'm guessing we need to find the values of A, B, and C. Right, so let's basically going to write an equation for each element. So let's start with the first element, which is this one, 2 lots of this one, and this one. So to make that really easy, before I do that, I'll just write A 0, 1, 2. I'll multiply the second one by 2, so then I'll get 2, 2B, 0, 6 equals 6, 6, 1, C. So yeah, an equation for each element. If I pick off the first element, which I've highlighted in orange, that will be A plus 2 equals 6. There we go. A is 4, easy. Right, if I pick off the second element, so 0 plus 2B equals 6, B equals negative 3, no, B equals 3. So there we go. I don't need to bother with the third element because I'm just going to get 1 plus 0 equals 1. Then if I look at the fourth element, 2 plus 6 equals C, so that means C equals 8. That easy. So it's very, very easy to work out. Right, you should now be able to do exercise 6A on pages 97 to 99 of the textbook.